I'll take a minute and talk about side loading screws. This is a piece of 1/8 inch steel plate, plasma cut off in the scrap bin. It doesn't really matter what the plate is. We don't care about that. Screws are M4 pan head slotted screws, stainless steel, pretty common. The point of this exercise is, well, don't worry about what the point of the exercise is. What I want to do is I want to take this screw, these two screws, and I want to apply some lateral force to them. That's lateral force. Now, one of the screws, as we can see, is not tight, is not inset to the metal. The shaft of the screw is going to take all the force we apply to it. The other screw is tight against the metal. I need to tighten it up a little bit before we do this, but we see the difference in the two. Does not take long at all to cut that right off. Now, let me tighten this one. The vibrations from the hammer worked it a little bit loose. I didn't put any Loctite or nut or washer or anything on here. So just make sure that's as tight as we can make it. Now it took about 2 seconds to cut the other one off. Now we're going to try to cut this one off. Decent likelihood that we're going to cut through. Now, if we look, I stopped trying the hammer, the compressor's running out of air. If we take a moment and we look, we've cut into the screw head pretty considerably. Try to get it to focus here. We cut into the screw head pretty considerably, but it is still intact. It's still on the base material. It's even, still tight. That's what we're talking about here. What does this mean in reality? Well, not a lot. It's a bench test I just thought of quickly to prove a point. But what it does mean in the real world is if you're going to put a screw in your clutch fork, you need to make sure that it stays tight and that you are not causing the shaft of the screw to take the lateral load. If the shaft of the screw is left to take the lateral load, that will happen. Pretty simple. How to prevent that from happening? Well, again, if you're going to make your own padded clutch fork at home, if you're going to put a screw in your clutch fork, rather than buy one from me, rather than buy one of the welded forks or one of the differently cast forks, or there's a million options. There's no real right or wrong. If you're going to make your own at home, do not, I repeat, do not countersink the hole. If you have to countersink the hole, if you feel some possession, some need, some burning desire to countersink the hole, use the appropriate bit. Do not just drill the next size up or 2 sizes up or whatever you want to do. Do not do that. If you let the screw head wobble, it will shear off. If the screw head shears off, well, you don't have a modified clutch fork anymore. You just have one with a hole drilled in it. That's pretty simple. Pretty simple explanation there of what I think makes a difference.